So in this question, we're going to consider how changing the size of the Earth without changing the mass of the Earth would affect the gravity. Now, a better way to actually put this, because sometimes people can get confused by just this concept, is to just think about the distance. So if I have mass 1 and I have mass 2, then the relationship of the forces between them, which is the force of gravity, actually, the arrows would be this direction, but would be related to the distance. So it's directly related to the distance, but is it directly related to the distance? The graph, when we do this, when we have the distance here, is called an inverse, but it's the inverse square law, right? So this is an inverse squared relationship. So RB's weight is 65 times 9.8, so we're just going to use regular Earth G to begin with, and we'll fill that in right there in newtons. That's RB's regular weight. And then now the radius of the Earth was double, so really we're saying twice as far. So we're 2 times as far. If we're 2 times as far, that's going to give us the inverse square law, and so the inverse of that is actually 1/4 less force, or 1/4 the force. So the force is going to be, you divide your original by 4. Now if the radius of the Earth was triple, we're basically saying we're 3 times farther away than we were to begin with. If we're 3 times farther away, then once again the inverse of 3 is 1/3 squared is 1/9. And so our gravity would be 1/9 of the original. And then now we're going to go the other direction. We're actually going to get closer. So when we get closer, the gravity is going to grow. It's going to be more. So the gravity is cut in half. So we're half the distance. And so the inverse of that is 2/1, which is squared. And so it's 4 times greater. And then, of course, we follow the pattern. 1/3 inverse squared is 3/1 squared, and so that's 9 times greater. So if you're able to get closer, if you're able to get closer to the object, that's closer, then your force of gravity goes way up. And if you're able to get farther away from the object, that's far, then your force of gravity goes way down. So your force of gravity, if you get really close to a black hole, it can approach affinity. And if you get super far away, then it can approach 0. Remember that term, approaching 0 force. Approaching, gotta write small here, approaching 0 as your distance gets farther and farther away. And that's how we take a look at this question.